Get the rest for us. Now this problem, if you have your homework from last week, it comes off the sheet that I gave you. So this is just a little review again of the mass. This problem with the fire extinguisher. Remember the fire extinguisher? So we've got this problem up here again. But they gave him like nerve agent. That's Gulf War syndrome. Because Saddam Hussein was known to use it. And I wanted to have kids one day, so I was like, I think I'll stay back. Started off with 500 grams Ag2O, went to the periodic table, found the mass of Ag2O. So she now has 2.16 moles of Ag2O from the 500 grams. So all we did was convert 500 to a different unit in the mole. So these two numbers are actually the same thing. Now we go to the balanced equation. She says, okay, she balanced the equation. She says 2 of these are required for 4 of these. You can see that here. 2 times 2 is what? So we have 4 right here. And her balanced equation shows you have a 2 there. So it's really 2 divided by 4. And then you're going to multiply it times the mass of silver to find the answer. So can anybody come up here and do this for us? I'll give you 10 points. Really close to 500 because you're starting with 5 and it's not going to be like 10,000. It's not going to be like 2.
That's not where I was. Oh, okay. I was getting there.
So would it be 2.16 times 4 and then divided, or would it be multiplied again?
Well, it's going to be 2.16 times 2 because 4 divided by 4 is 2, and then times 107. So it should be around 500. Looks like it's going to be a little less.
What kind of size did it have on the ACT?
460. Very good. Graham?
Compared with the volume of the empty space. Because gas particles are far apart, they experience no significant attraction or repulsive forces. Gas particles are in consistent, random motion. Particles move in a straight line until they collide with other particles between gas particles and elastic particles. Or with the walls of their container, as shown in figure 12.2, collisions between gas particles and are elastic. An elastic collision is one in which no kinetic energy is lost. Kinetic energy can be transferred between colliding particles, but the total kinetic energy of the two particles do not change velocity. Therefore, all particles do not have the same kinetic energy. Temperature is a measure of the average kinetic energy of the particles in a sample of matter.
Okay, so at what temperature does helium become a solid? At what temperature does helium become a solid? Sophia? Now, you've seen helium in balloons, right? So can they get helium out of the atmosphere, Jacob? Or Jake? Can you get helium out of the atmosphere? Yeah, so it goes to outer space, so you can't. So once the helium leaves the balloon, it goes to outer space. So how do they get helium on the Earth? How are we getting it out of the Earth? Is it found in a rock? Is helium found in rock? Or is it found in methane gas, like when we're like drilling in the ground? Which one do you think? You think it's in a rock bound with something else, or you think it's found like in a gas mixed with methane in the ground? Actually, it's found in a rock. I think the rock's called cleveite, and what they do, they add some acid to it, and that frees the helium. Now the question is, at what state is helium a solid, Hannah? At what temperature is helium a solid?
Negative 13 degrees.
Didn't ask you.
Anybody know?
It has to be
Michaela?
Is it 20 degrees Celsius or is it freezing?
0 degrees Kelvin. So all substances are a solid at this temperature. You might want to write that down. That's a really good note to remember. All substances are a solid. You know, we're talking about states of matter here. All substances are a solid at 0 Kelvin.
How cold is 0 Kelvin?
Very cool. Now, I used to think that if you got to 0 Kelvin, your temperature is associated with volume. That's Charles' law. So the thinking was, you can see in the diagram on page 403, figure 12.2, the thinking was if you change the temperature, you get the volume to 0. That's why they call it 0 Kelvin, because temperature and volume have a relationship.
Who's Kelvin?
He's the person they're honoring for this relationship. So there's a relationship between the two. I believe it's direct. I didn't look at that this morning. It's not in my complete memory. I haven't talked about it in a while. But there's a relationship between volume and temperature, Charles' law. And the idea, this is the important part, the idea, Michaela, or Garrett, the idea is that, or the thinking was that you could take the temperature down to absolute 0 and you'd turn matter into nothing. You would create 0 volume, basically, is no matter. So they actually got below absolute 0. If you really wanted to prove the steady state theory, this is how you do it. The steady state theory is where you can turn matter into nothing. Just adding time to the equation is like creating religion. That's my big problem with the Big Bang, is that if you can't do it in the lab now, adding time to it is making it a religion, because you have no basis for it but your own opinion. That's a big problem with me. And there's a lot in the community that are like, well, you know, if just something out there or nothing out there can make something, then that's kind of like saying your data can just come from anywhere. You can just start making up data. And that's not science. That's called not sound science or fiction. If you just make up data, go try to present that somewhere. They're going to like not follow you or believe you, because truth always, you know, well, you're going to eventually be found as being phony, because you're supposed to be able to replicate things. You're supposed to be able to do it over and over. The whole idea behind science is that you can repeat this, and then the reason why you want to repeat it, it prevents people from being lied to and cheated. People don't like being lied to and cheated. So if you're saying nothing can turn into something and something can turn into nothing, you can create lies and you can cheat people by doing this. You could sell somebody something and then eventually it turns into nothing. They're going to be like, hey, what'd you sell me? Well, I sold you that. Ain't my problem, it turned into nothing. And so it creates problems that way from a matter perspective, because things that we sell are made of mass. So that's why 0 Kelvin is very important. Absolute 0. They got to this temperature. They're actually in particle accelerators. They're trying to get to that temperature, then smash it, trying to break it apart. So they're still trying to prove the steady state theory. So, you know, it is what it is. People are going to try to do what they do to promote truth. I mean, I definitely want them to try to do that, because I don't want people to be, you know, taken advantage of. Not good, right, Garrett?
There's 2 of that.
I haven't had it since before I got a little doubtful for you right now. No, bro, like I've not had breakfast. I'm so
Wait, wouldn't it just be 2? It would be 2 AG? Right?
Okay.
Is that it? Because, wait, hold on. Or would it be, because since we have 2 of these, so that means we have AG.
Hey, Mr. Steiner, you got a microwave?
Unfortunately, I don't. Somebody cooked some popcorn in a microwave last week and about set off the school fire alarm.
Is that what that was?
Because they walked away from it.
Friday?
Yeah.
No way.
Yeah.
We were wondering what. You know what's crazy, Mr. Steiner?
She threw it out the window too. I'm like, hope you didn't throw that on the roof.
Hey, you just told me I had to wait. So you get something to drink. Go already, jeez.
Excellent job. First step, balance the equation. Nice job on that.
So now we just have to look at it. So, does that mean that this equals 500?
No.
Or this is 500 grams of this, or it's 500 grams of that?
They've actually given you 500 grams. The balanced equation is the recipe. So you follow the recipe when you make in whatever you're trying to produce. So if you're given an amount, like if your boss places an order, let's say the Kentucky Derby's coming into town, you might need a little bit more. That's where the 500 comes from, right? So if you're looking up here on the board and this, you think you've never seen this before, then obviously you didn't look at the sample problem from last week on the back of this, because the sample problem is basically what's on the board there. If you look right here, it says what mass of silver will be produced when 125 grams of silver oxide Ag2O decomposes. And they have the balanced equation there. So all I'm doing is going over the sample problem from last week. It's kind of a last review of this concept. 1500 or 2 or 3. Just nice job, Zane. Excellent work here. So this is the strategy to solve for stoichiometric problems.
And structure their arrangement. Determine the chemical properties of matter. Composition and structure also affect the physical properties of matter. Based solely on the physical appearance, you can distinguish between the solids and liquids, as shown in Figure 12.1. By contrast, substances are gases at room temperature that usually display similar physical properties despite their different compositions. Why?
According to Charles' law, you should be able to take a gas, which is a state of matter, and turn it into zero volume. That would be Charles' law. Now, the problem is when you take a substance like helium, at what temperature does helium become a solid? Anybody know? What temperature would helium gas, which is in your balloon, become a solid? Close. It's like 0 degrees Kelvin. The lowest temperature possible. All substances are solid at 0 Kelvin.
What's Kelvin relative to like Fahrenheit?
Well, look in the book on page 445 and you'll see the Celsius would be temperature would be around negative 273.5. They've actually got a little bit below. They thought it was 273, but it's actually a little bit below that. Negative 273.15. And that's the temperature at which helium becomes a solid. Now the thinking was, if you look at this diagram, right, if you have a gas that has a large volume, here's your volume 800 milliliters, right? What's zero volume of a gas? Right, 0. The problem was that the volume doesn't become 0. The thinking was that it would, because the graph is showing that it will. However, helium becomes a solid that has volume. You can measure a solid, right? So this right here disproves the steady state theory, that is changing something to nothing. That's the thinking. Now, just adding time to it, that's what kind of creates a religion. If you can't prove it in the lab now, by just adding time, you're thinking one day that it will.
So we created nothing, or something.
The best way to prove that something and nothing are interchangeable would be temperature. Because as the temperature, this is what it's predicting, as the temperature drops, you should have 0 volume. So if you get below absolute 0, you should be able to stop the movement. If you stop the movement, this whole chapter we're reading right now is about motion. So if you were to stop that movement, you could predict that it would not know where to go next because you ceased its movement. You basically kill it. You know, if you get it to stop, it's dead. It's not moving. Like when you die, you're not moving, you're dead. Kind of the same idea. Most of us die. I mean, Lazarus supposedly rose from the grave, but a lot of people are not doing that. You know what I'm saying? Most people are dying and not getting back up. So death is, you know, the evidence of stopping. It doesn't start again. Like if your parents die, they're not going to get up and start again. Like you kill it, it should, like the gas should stop and not come back to its original state. It should disappear. That's the thinking. But at that temperature, absolute zero, helium is a solid. At what temperature does helium become a liquid? Or gas, that is, boils. What temperature does it change from a solid to like a sublimation, direct from a solid to a gas? No, just like half a degree above absolute zero, it becomes a gas again, or it boils off. And sublimation typically occurs typically when you have drastic temperature changes, like going from 0 Kelvin to, let's say, 25 degree Kelvin. It's going to skip a phase. But if you were to go slowly, you would be able to keep the molecules stable, because the temperature change is driving them to go faster, like the diagram's showing you. Nice job, Michaela. 25 that the example was, and change it to 500 to get the correct answer for the number of, or the amount of silver. All right, so if you get a job somewhere and you start working there, typically they're going to train you. And this is training. They're going to have some examples. Okay, there's like, let's see you do these examples first, before they let you go out and try things like on your own, come up with your own recipes and things like that. Does everybody understand that? Most banks will not loan you money to start like a restaurant unless they've seen you work somewhere else before. I mean, I wouldn't loan you like $1 million to start a restaurant if I didn't know you could cook anything. You'd have to show me you could cook something first before I give you $1 million. Because you could just be like, making hamburgers into, I don't know, something weird.
I don't know. Is this right or not?
Looks fantastic. It is right. She is correct. Excellent. You can make hamburgers into ice cream. That's some of that hamburger ice cream.
Solids and liquids, as shown in Figure 12.1. By contrast, substances that are gases at room temperature usually display similar physical properties despite their different compositions. Why is there so little variation in behavior among gases? Why are the physical properties of gases different from those of liquids and solids?
Matter based solely on physical appearance, you can distinguish between the solids and liquids as shown in Figure 12.1. By contrast, substances that are gases at room temperature usually display similar physical properties despite their different compositions. Why is there so little variation in behavior among gases? Why are physical properties of gas different from those of liquids and solids?
Really, like helium down to absolute zero or below, and I stop it, what would I do to it?
I don't know.
Now, if you one day stop breathing, what happens to you? You die. Now, if you take a substance to absolute zero and you stop it from moving, you basically are killing it. You're stopping it, and the probability of it knowing what it's going to do when it comes back is zero, because it doesn't have the data there for that. You turn it into nothing. All right? So if you can stop motion completely, then you have, changed its memory, is the thinking. You've killed it. Just like if somebody kills you, if you have a head injury and you come back to life, the probability of you knowing anything is going to be very slim to zero. That's what was interesting about Lazarus. That's what I've heard. Supposedly he was raised from the dead, but he remembered things. So that's not typically the case, because death has an effect on memory, the body's memory, that is. So Keep that in mind that if you take a substance down to absolute zero and you stop it from moving, you basically turned it into nothing. Zero volume means nothing. That's the definition of nothing. Like if I hold up a beaker or a graduated cylinder, I hold up this beaker right here, and I say, hey, there's nothing in the beaker. That's what I'm talking about. Zero volume. Like there's no water in this beaker. Zero water. No volume. There's no volume of water in this beaker right now. They came up with a religion where when you eat beans and you pass gas, they thought part of your spirit would leave you. So if you just make up things that you don't have any data on, like we don't have any data yet of turning something into nothing, and you just say it's going to eventually happen, that's when it gets into this kind of, you're promoting a religion when you don't have any current data to support it. It's craft, right? And we sent her to outer space because we're trying to find new places to live. But we didn't know if we took a left, the temperature would actually drop in the universe. So she hit the below 0 Kelvin zone, and she just disappeared into nothing. Yeah. So that's kind of a problem with accountability. Like if we sell Lily a Corvette, and then she puts it in her garage, and for some unknown reason, the temperature drops below 0 and her Corvette disappears. Absolute 0 and it's gone. People don't like being lied to. Right? That's a big problem. It's an accountability issue.
As gas particles are far apart, they experience no significant attraction or repulsive forces.
Keep going.
Gas particles are in constant random motion. Particles move in a straight line until they collide with other particles, or with the walls of their container, as shown in figure 12.2. Collisions between gas particles are elastic. An elastic collision is one in which no kinetic energy is lost. Kinetic energy can be transferred between colliding particles, but the total kinetic energy of the two particles does